Hello, let me share this on Twitter. Let's see. I'm going to share it on Twitter and Facebook, and then we'll take a look at this here. Okay, let me open this up over here on my other computer to make sure the audio and everything is right. And it is. Okay, I see 7 of y'all are watching right now. Appreciate it. Let's get into it. So this is what I want to show you right off the bat, just to tease you a little, because I'm not going to show this all right in the beginning.
I tell people, well, that looks cool right there. I tell people I'm building a robot antenna, because that's kind of what it is, you know?
Yeah, on my tracking. Somebody asked me what I'm doing. I said, no, I can't tell you. It's top secret.
Yeah, that's another thing I don't know how to handle is the coax as far as it getting tangled up. I'm going to put a camera on mine.
Alright, so this is Darrell W4CX's satellite ground station. He lives in Raleigh also, which is where I live. And this is footage I filmed yesterday. I went over to his home and took a look at how he installed his tripod. That's the main thing I'm trying to figure out right now, is how I'm going to screw it into the roof, how I'm going to bolt it down, or whatever I'm going to do on the inside of the attic to make sure it stays put. So we went over there, and he's also got a sat-nog station, and he wanted to show me that. I've been over to his house one time before this, and I wanted to, but he set up sat-nogs since I have seen him the first time. So I went over there and checked that out, helped him upgrade it because it runs Linux, and he's not a Linux guy, but I am, so I helped him upgrade his sat-nog station. So I'm going to talk about that more at the end because I like to do these videos in chronological order. So I want to start with what happened since the last video, and then I'll get to what happened yesterday with more footage from Darrell's setup. Okay, so the last video was on, anyway, not long, I guess, yeah, not long after the last video. I guess the last video was on February 2nd. The day after that, an M2 employee saw my video, the live stream, and he messaged me and he wanted to give me some advice about the Leopack. The first thing he also offered very kindly to give me his cell phone number if I had any questions or issues, which I was like, that's awesome, customer service. But the main thing was, he said, is the Leopack new or is it old? Because we changed it within the last 6 months, and they actually shortened one of the elements so that it would be a little bit higher frequency. This is on the 70 centimeter antenna. And I was like, actually, I got it from somebody else. I don't know, how old it is or anything like that. And we basically decided that I just need to look at the manual, get the latest manual, see what the measurement is for all the elements, measure the elements. The change they made apparently is less than a 16th of an inch. So one of the elements is a little bit shorter, so I'll measure it and see if it's what it should be based on the latest manual. And if one of them is a little bit longer, that's the one I'm going to have to, grind down a little bit or shorten somehow. He also suggested, he saw my video where I have the fiberglass crossboom that I got from Matthew NJ4Y. I wasn't planning on using that crossboom because it's bigger and longer, and I was like, I don't want to put more weight up there than I have to. But the M2 employee told me, and I'm not mentioning his name, so I didn't get permission from him to mention his name or anything yet, so I'm just going to say the M2 employee. So the M2 employee, since I'm just talking so much here, I'll just zoom this in a little bit. What's up, Manuel? Thanks for tuning in. So the M2 employee told me to use the fiberglass crossboom instead of the M2 Leopack crossboom because it was bigger and stronger. And I said, okay, I'm going to do that. So I'm going to do that. So he told me to check for the length of the element and then also to potentially use a smaller crossboom, or the bigger crossboom rather. Okay, so I actually have some video of that crossboom to show you. So let me show you that. So this is the crossboom.
Okay, this is the fiberglass crossbooms laid down next to the Yaesu G5500. And you can see that they're very long and they're much bigger than the M2 crossboom will be, which I won't be using because I was told this one's better. They're stronger. So they just go on over these aluminum, or this aluminum piece, which I believe goes straight through. So maybe not. I don't remember. Anyway, that's that. You can see how that works. It goes over, and then that screw holds it on. So
I actually also have a video of the metal crossboom. This comes with the M2 Leo pack. It's actually 3 sections, 1, 2, 3, and it's definitely not as strong as the fiberglass one. The metal is fairly thin. Obviously, it's strong enough, but if I have the fiberglass one, why not use that? Additionally, fiberglass isn't going to interfere with the radiation pattern of the antennas, though apparently it didn't really affect it much anyway, because this is what they provided in the design. So you can see how thin it is compared to the fiberglass one. The fiberglass one's probably like, I don't know, 1/4 of an inch thick or something. And yeah, so that's good to know. So that's what I learned from the M2 employee, those 2 things, that make sure my elements are right because one of them might be shorter, and then also to use the fiberglass crossboom. Okay, a really cool thing happened on, I don't know exactly when, but sometime between last weekend and the weekend before that. I was on Twitter and I found NS3L somewhere and I wanted to go check his profile. I've talked to him many times and he's a well-known satellite operator, and I was just scrolling through his profile for some reason, and it's quite a like many hams. He's got a lot of ham history, and it's all in his profile. And I was just scrolling through, and finally I get to his satellite setup, and I got really excited because it's basically just like what I plan on doing, except he has bigger antennas. So the G5500, it's exactly the same. He has the Advanced Receiver Research preamps, which I'll be using. Those are exactly the same. This is the same fiberglass crossboom. He's using M2 antennas and for 2 meters and 70 centimeters, and he has a WIMO helical 1.2 gigahertz antenna. And I have the same brand antenna. Now all these antennas are a little bit bigger than mine. So also he has switchable polarity, so he could switch between right hand and left hand cross polarization. I don't have that, and I don't plan on having that. But so he has 14 elements on 2 meters, and I have 8. He has 30 elements on 70 centimeters, and I have 16. And his helical antenna has 21 turns on 1.2 gigahertz, and mine only has 10. But other than that, it's very, very similar, which is great because I really found the way he mounted his preamps interesting. Most people mount their preamps on the mast, and he put it on the boom, and it just looks really clean to me, and it seems like it might avoid getting coax snagged on different things. Sometimes the coax will snag on, it'll get tangled up and things like that. So I'm really interested in potentially replicating his setup. Here is the preamp and here's the WIMO. And I actually emailed him asking how he mounted the preamp, because he seems to have an extra plate, and they only send you 1 plate. And he actually sent me a whole bunch of close-up images just a while ago, and we chatted on email about this. So here are the close-up images. So this plate is the back of the Advanced Receiver Research. Normally this plate would be flipped right here, and then that that hole there, there's another hole there over here just like that, and it would be aiming down, and then you would put this sort of a U-bolt onto the vertical mast. So he actually got another plate from Advanced Receiver Research and fashioned it onto the one attached to the preamp, and then basically got 90 degrees off, and that's how he mounted it, which I might do something similar. One other difference between his setup and mine is you can see there's this middle connector, and he doesn't have anything on it. What that's for is the power. That's where you give it 12 volts DC. So he's actually powering his through the coaxial cable, and I wasn't planning on doing that. What I was planning on doing is something I learned from Mark in MH, who helped me do the Eris contact I mentioned. What I was going to do is basically have rotator cables for as L, and each rotator cable I'm going to order with 2 extra conductors. So one will be for the 2-meter preamp, one will be for the 70 centimeter preamp, and then I can turn them on and off, from the shack and things like that. Now, Steve NS3L, like I said, is powering us through the coax, and I thought that was something anybody could do. I thought I could do that if I wanted to, but I didn't want to. But he told me that you actually have to get a choke installed when you order it. They either put the choke in there for you, or you have to send it back and they install the choke. And that blocks, I think without it, the DC doesn't get through, something like that. I can't remember exactly what he said. Another reason I wanted to not use that method is because I don't know what radios I'm going to use, and not all radios have the ability to send 12 volts DC up to the preamp. I do know what radio I'm going to use. I'm going to use the ICOM IC910H, and I guess at the time when I got the Advanced Receiver Research, I didn't have that radio, and then also I wasn't sure if I might use different radios, and in fact, I think I'm going to use an SDR for receive when I work to linear satellites, so I can see the whole passband, and that would make inserting 12 volt DC even more complicated. So with this external power, I don't have to worry about that at all. So here's some more pictures. Okay, another thing he told me, so there's his WIMO helical antenna. You can see the circular elements. Let's see, is that all? I thought there was another one. Yeah, let's see. Yeah, there's more here. Okay, so this is the back of the WIMO 1.2 gigahertz antenna. I believe this little component, this little metal piece here is, he told me that he had to add like a muffler something to basically mount this WIMO on a crossboom instead of having it mounted vertically. I think that's different. I know I've looked briefly at the hardware for mine, and it has these 2 pieces. I don't think it has that. So I'm not sure. I guess normally this here might go through that. That's what it looks like. Yeah, so normally the boom of this antenna would go, I'm pretty sure it would go through that. But why didn't he do that? I don't know. Anyway, that's something I'll figure out later, and now that he's told me that there is an issue with mounting it on a crossboom with the existing hardware, I won't have to figure all that out on my own. He's already figured it out. So more pictures of the brackets there. So his M2 antennas are switchable polarity, and the way you do that, if I understand correctly, is you have a relay. So you have like a special, I think it's probably this system right here, and you just power it. So you send power up to it. That's what this cable here is. The kind of looks like it's copper wire, speaker wire kind of cable. So that powers the relay to switch basically the feed point. Basically, the antenna has separate feed points, one that is right-hand circular polarization, one that's left-hand circular polarization, and the relay switches from that feed point to the other. So now there's more to it than that, but that's basically how it works. And I'm not going to do that. So I'll have some fades when the signal switches polarity sometimes, but I'll just deal with that. Okay, so thank you, Steve, for all these great photos, high quality, high resolution photos. Really, really helpful. I'm really excited about having something to base my setup off of potentially. Okay, let's see what I have next in store for you. Okay, so last weekend I did some board I prepared some boards. Let me just get the videos and it'll be obvious. I prepared boards for the inside of the attic to hold the tripod. Cut video. 4 minutes. Alright, there's a little video of me cutting the boards.
Okay, so one tripod. Got the boards ready, so that's pretty good. My 3 boards here.
Alright, so those are the 3 boards, and I'll show you what I was planning on doing. Let's see, 0225.
Right around there, and I have panels to put against the beams to increase the strength of the bolts securing on the inside. So here's one panel. Here's how it's going to work.
Thanks, Bob, for tuning in.
All right.
AJ5C.
So here is the that circle right there is where I'm thinking the tripod foot will be. And then I have this panel here. And the idea is to basically screw the panel into the 2x4s and then have the bolt come through somewhere in the middle of the plywood here. Now, my concern is that this plywood on the roof plywood is fairly thin. You can actually see the shingles right there, and I can put my finger up here and see that it's, I don't know, 1/4 of an inch or something like that. I'm not really good at measuring things like that, but it's thin. So like, I guess my thing is maybe I could put something in between here in the plywood so that it would be strength from here to there. My concern is if I tighten the bolt too much, it'll compress this board here. I don't want any sort of bad compression. And also, if the tripod were to get pushed one way, I guess the foot could come.
Alright, so that's what I wanted to show you from that video. And I decided, because of that gap, it wasn't right. So I'm not gonna do it with that gap, and I'm gonna do something different. One other thing, and I'll explain that later, I figured out what I wanted to do after I saw Darrell's setup, who I showed a clip of earlier. One other thing I had been thinking about over this week was using magnets to basically have go on top of the roof with a magnet and have somebody inside my attic, and then I can move the magnet around on top of the roof. They can stick it up to the bottom and they'll be attracted, hopefully, if they're not too far apart. And then I can identify what spot under the attic where there aren't, say, a joist or a nail, where those spots are on the top of the roof. So I'll basically use the magnet to help me find out the best place to position the tripod before I drill the holes, because I don't want it to go through the joist. I don't want it to hit a nail. You know, I want things to be lined up properly. So I've got a magnet, and I'll show you what I mean by how I plan on using the magnet. I didn't mean for that to happen when I was filming this. This is what I was trying to do. So you can see they do hold and they do have attraction fairly far apart, and I think the roof, like I showed, is fairly thin. So I think this will work. And if it doesn't, I can get some rare earth magnets that'll probably work even better. So that brings me up to yesterday. So let's take a look at the rest of videos from Darrell's station. Let's see, here we go.
That twisting motion,
Yeah.
if you think it's bad now, you should have seen it before.
All right. Well, yeah, tell me about your setup here, Darrell. I'll film you.
All right, well, this is the Squared Antennas set pack. I believe it's a 24 element, 432 megahertz circular polarized array. This is 344 over here. The antennas terminate into the block here. This is kind of like, well, this is the 432 preamp and the power line for it. I'm feeding it with LR400, and this happens to be just a regular TV antenna, so it's not part of the ham array. But essentially, I started out with a 10-foot mast in this little I guess this is like a 3-foot tripod. A little bit unsteady for this kind of application, so I wound up having to drill all the rivets out of these points on the corners and put in actually stainless hardware. I also built this foot down there, which you saw earlier, which was basically a couple pair of angle irons that lock the mast down to the roof so that it tries not to twist. This is a lot of momentum as this thing turns and stops, and because the satellites travels relatively slowly, it can turn and stop a lot. And when it does that, it keeps on shaking, so this minimizes that as well. But everything comes together. I've got another piece of coax up here for a future 6-meter beam. I don't know where I'll get to that point or not, but it's the idea behind it. And then of course the rotor cables come down all the way to the edge. They drop into the basement down below and over to the shaft.
You got a 80-meter dipole here, or what?
Yeah, that's a Carolina Wyndham.
Okay.
160 through 10 meters, and it comes across here and also drops into there as well. At the moment, I have a little bit of an RF problem, and that with a quick balun or a choke that I'm going to put on here. But this has been up running for maybe 5 years, I think.
Yeah, I have the same preamp.
Yeah, those are good. You have the 2-meter as well.
Yeah, I have the 2-meter as well.
The biggest problem I have with this is being able to articulate antenna, maybe a Lindenblad or quadrilateral array.
Okay.
Yeah.
So this is the tar stuff.
Yep.
Oh, this is where it was, because he had this mounted once. He took it down, he thought he was going to move, and then he came back up and did it again.
Right.
So that's what that was, probably.
Right.
Previous mount.
There's one there, one there, there's one there, and there's one there. Those are the 4.
That's the original. I really am impressed with how you've strengthened this tripod, especially with that centerpiece. That's
I probably need to do some more, but I got most of them swapped out.
yeah.
So
You're not the only one that's done that. I've heard people say to do that.
Yeah.
So
What I'm talking about here is they are riveted, so people remove the rivet and they connect it with a bolt and nut.
that's pretty common. I guess I could do that too if I wanted.
It's not hard.
So that's the thing I'm worried about. My tripod is so tall that, and my pitch. My roof's pitch is really high, so it's gonna be hard to like work with this.
You
So
got to realize that this thing is probably a good 15 pounds, or maybe more than that. So when you're up here, you got to pull the whole mast and rotor together up above here. It's almost like you need a gen pole of some kind.
okay, so basically you put the mast and the G5500 up first, and then you put each antenna and boom on, So you installed the antenna on the boom, on the ground, or put it on the roof, and then you basically held it and slid it on here?
Yeah.
That's how you did it?
I put a step
Step
ladder over this peak
Yeah.
and climbed up the step ladder with this piece and just sort of worked it into to there and then tightened everything down.
Okay.
And then I did, of course it was very unequally loaded at the time, but I just rotated it around.
Yeah.
The biggest problem.
Alright, that's what I wanted to show you from that video. I've got another one inside the attic that will show you how he did that part.
Darrell W4CX. We're here in Darrell W4CX's attic, and he's got one tripod leg over there by that 2x4s, the 2x4s.
Yeah.
He's got one here and then another one over here. And the way he did it is he drilled holes through the roof, through the where the feet were going to be, and then he came in here and looked around, saw where the holes were, and then he put the boards there, and then he secured the boards with screws so they would stay there, and then he went upstairs and drilled a hole for lag bolts, and then big lag bolts, and you can see one here that came through right there, and then he used similar ones. Well, actually, yeah, there's a lag bolt somewhere in here.
Each end of the cross ties too.
And then these 2x4s are just nailed in here. See, there's a nail.
And if you look over here, you see the two bolts that are holding those things
So those two lag bolts just hold the board here.
in place, right?
These boards. But basically the tripod is screwed into these boards. That's how it's secured. So the way I was going to do it is use bolts and nuts and everything. And this here is just to hold that board into that one. So that doesn't go into the tripod at all. Right. These bolts are just to hold that. So. I was like, how is it, why do we have so many legs?
Yeah.
Okay, so that's what's going on here. So leg 1, leg 2, leg 3, and then the mast is secured here with a custom, you've modified the tripod to be able to do that.
Two pieces of an angle bracket set together and drilled so that it forms a U.
Mm-hmm.
And the center of it's tied down here, and then laterally.
So that's what you already saw. So after seeing that he used 2x4s, and I didn't want to have the gap between board attached to the joist and then the actual roof, I decided to use 2x4s as well. So I went to Lowe's right after this, and I got myself a 2x4, and I got myself those magnets. I'll show you the 2x4. There's nothing special about it, but it's in here. There it is. So my plan is to, let me increase my size here. My plan is to basically just use 2x4s and put them in between the joists and then screw from each side of the joist into the 2x4 to hold that there. But that's after I find the right spot in the attic. So I'm going to do the magnet thing. Once I find the right spot, I might have to cut I might have to grind down some nails that are coming through the roof to make room for the 2x4. And I'll secure the 2x4, then I'll go back up on the roof, I'll drill holes and for the bolts, and then I'll have bolts go through, and I'm gonna have a washer and nut to hold that bolt on. I'm not gonna use big lag bolts like he did. He was a little more adventurous, shall we say, in mounting that tripod. Like he just went up there and just drilled and then found out where he was. Just a second. Found out where he was on the inside of the attic, and one time he went through the joist. I don't want to have to move the tripod and re-drill because this is not my apartment. This is a rental. My landlord said I could do this, but I want to make sure that I make as small of a hole as I have to make and as few of holes as I have to make. So that's pretty much where I am now. The other concern I did mention to him, you might have heard me say it, is that my tripod is much taller than his. It is basically, and so with my tripod, it's 5 feet. His is 3 foot. So if I have a 5 foot mast, I think, and then the mast goes in the tripod. And I had it set up on a previous video. If you saw the other one, the rotator would basically be almost up to my ceiling here in this room. So I'm gonna have to like basically the boom is gonna be like way up ahead of me, and my roof is pitched much more than his. So I'm really concerned that I'm gonna have to get a smaller tripod, and for sure I'll probably want to trim the mast I have. So we'll see what I end up doing. One of the things good about my tripod is that it's heavier. It's heavy duty compared to his. So even though it's taller, it's more heavy duty. So we'll see. Okay, how long have I been going? Does it show me? 30 minutes. Okay, well, that's it. Well, let's check the chat. Appreciate y'all watching. Andrew says that that's what he did. 2x4s in between the roof trusses. Yeah, and if you use screws with a drill, it's 100 times easier and quicker. Cool. Well, thanks for watching, y'all. I'm going to try to do these not every 2 weeks, but every week so I can just have a smaller video. They're easier to prepare for if I do them with less information. So this one actually took like 5 hours to prepare for, basically, which is crazy. But it's certainly a lot less time than it would have taken to edit a nicely done video. So a little rougher, but it's live. We get to kind of chat. That's kind of fun, and still get the content out there. So thanks for watching. Space Comms is sponsored by Nordic PC. If you want a new custom built PC, check out Nordic PC. Also, Mac Doppler is the software created by Dog Park Software, which is our sponsor, Dog Park Software, and also Arrow Antenna. And I have patrons too. So thanks y'all. Appreciate it. 73. I'm John Breyer, KG4AKB. Bye.